Okay, so apparently I didn't realize that this screen recording software has a time limit on the video, so it cut me off and I got almost all the way through the entire video before I realized it. So I'm going to pick up right here where it cut me off, and we're going to go with rubidium 85, and it's going to be 100% over 140%, and that's going to give us our abundance of rubidium 85, and we're going to do the same for rubidium 87, except it's going to be 40 over 140. Alright, so we can do this in our calculator real quick. And we're going to take 100 divided by 140, and that's going to equal 0.7143. Then we're going to take 40 divided by 140, and that's going to give us 0.2857. When these two numbers are added up together, it should be about 100%, and it is for us. And so what these numbers here tell us is that in this original sample of rubidium, about 71.43% had a mass of 85. 71.43% of those rubidium atoms had a mass of 85. 28.57% had a mass of 87. Okay, what we need to do is basically take a weighted average of these masses, 85 and 87, and here's our percent abundance. If you've ever had a class that your tests are worth more than your homework, that's a weighted average calculation. We're going to do the same thing here, taking the average, but accounting for the fact that we have more rubidium 85 than we have 87. Okay, and so the atomic mass is going to be equal to 85, the mass of this isotope, times the abundance. Okay, so times 0.7143. Then we're going to add the other isotope, 87, times 0.2857. Adding those together, I'm not going to do this one in my calculator because I just did it like 10 minutes ago before I realized that I was not being recorded anymore. But the atomic mass of rubidium is 85.6 atomic mass units. And we know that my unit here is AMUs because I'm talking about, my question is asking about the atomic mass, not the molar mass. Okay, so the atomic mass is in AMUs. And if we think about this answer, 85.6, our final answer, we've got more rubidium 85 than we have rubidium 87. And so our weighted average takes into account this abundance. And so our final answer should be closer to 85 than it is to 87. And it is very much so. Okay, so according to our logic and our reasoning, we should do, or this answer should be the correct answer. So we have 85.6, and our units here are AMUs, and we can submit, and it's going to tell us it's completed, but I know that that is right. Okay, so that's question number 12. One in one video, finish it up in the second video. We're going to go now to question number 17. Okay, so you can find a new space to write down some notes or click over to number 17 on your homework, whatever you wish. Okay, so number 17 is one of those questions that's going to auto-populate and give you a different element for every student. Okay, so this one is giving me tungsten right here, and actually I'm going to restart this, and it might give me something else. It might not give me tungsten. Hey, it's got barium. Okay, so I've got barium for this example. You could have any element on the periodic table. Okay, but the process of finding the answer to this question is going to be the same no matter which element you've got. Okay, So, what we need to do, we've got the mass of barium is going to be equal to 137.33 AMUs, or atomic mass units. What this is telling me is the mass of a single barium atom in atomic mass units. The question is asking for the mass of a single barium atom in grams. So we need to change this atomic mass units into grams somehow, and we're going to do a unit conversion to make this happen. Okay? The odd thing about atomic mass units is that it's a very arbitrary unit, and it doesn't really mean a whole lot. So chemists a long time ago just came up with this unit, atomic mass units, to make these numbers mean something. Okay, we cannot actually measure one single AMU. It's too small. We don't have the ability to do that. Okay, but we do have the ability to measure the mass of moles. So when we do that, we get to the same number, 137.33, but our unit changes to grams per mole. Okay, so the mass of barium, and this would be 1 mole of barium, is 137.33 grams per mole. Okay, we need to change this grams per mole, and we need to find out how many grams per atom we have. Okay, we're going to put this into a track. We have 137.33 grams per mole. And the way that we're going to use this unit in our track, we have a numerator and a denominator in our unit. And so when we have that, we're going to put a numerator for my gram, and the denominator is going to be the denominator of this unit. Okay, so in the starting point of your track, you're going to have a unit on the top and a unit on the bottom. We need to get rid of this moles. So we need to be able to cancel this out because we want to be left with grams. How many grams for one single atom? Okay, so just like always, normally we cancel top to bottom, our units. This time we're going to cancel bottom to top. So we're going to put moles up here. Mathematically, it's going to be the same process. These units are going to cancel. Okay, and we know how many atoms are in 1 mole. Okay, if you don't remember this number, you will after I tell you. It's 6.022 times 10 to the 23rd. I'll erase and give myself a little bit more space. 6.022 times 10 to the 23rd atoms in 1 mole. Okay, so if I know that 1 mole, and if you don't remember this Avogadro's number, that's something that you should probably go look up and do a little bit of refreshing on your own, because this is an important thing in this class that we'll need to know and understand. Okay, so basically 1 mole of barium contains this many atoms, and it weighs this much. So if I take this value, 137.33 grams, divided by this many atoms, it's going to tell me the mass for 1 atom. Okay, my moles is going to cancel, and I'm going to take 137.33 grams divided by 6.022 times 10 to the 23rd atoms. When you put this into the calculator, a couple of students were having some issues with this earlier. We need to make sure that the calculator reads this the right way. If you are getting something other than what you think you should be getting, when you type this into the calculator, try putting everything on the bottom into parentheses. That will help keep the order of operations the same in the calculator. Okay, so when you do this, we're going to get the mass of a single atom of barium, and this should be a very small number. most likely something times 10 to the negative something really, really small. 6.022 times 10 to the 23rd. And I get, and it tells me over here, express your answer using 4 significant figures, so I need to keep 4 sig figs. I'm going to get 2.280 times 10 to the negative 22nd. Okay, and again, this means that I'm moving this decimal 22 spots to the left, and so that is a very, very, very small number. And that would make sense if we're talking about the mass of a single gram. Okay, so then we can come over here and 2.280 times 10 to the negative 22nd, and it's already got my unit in here for grams, and I can submit, and bada bing, bada boom. It doesn't tell me it's correct, but it is correct. Okay. Hopefully these 3 questions that I've worked out for you kind of help you to get started on or continue on this chapter 2 problem set. If you've already completed these, I don't think that you're able to go and undo your work and resubmit them, but maybe if you didn't get them correct originally, now you at least understand the process of how you do get to the correct answer. Okay. I chose these 3 questions, number 9, 12, and 17, because I think there were like 6 or 7 people that had completed them at the time when I chose them, and the results were worse than the other questions. They weren't terrible, but they were just, the percentages were down. So I chose them in hopes that I could help kind of alleviate some of that stress. Okay. Your job for class today is to finish up or continue working on this chapter 2 problem set. The deadline or the due date has been moved to Sunday at midnight, not Friday, so you have a couple of extra days. That was another thing in feedback that I saw, so you're welcome for that. You've got a couple of extra days. Make sure that you take advantage of it and give me the best possible work that you can within that amount of time. Okay, so you're not, hopefully not as rushed. You got some more time to kind of really focus and give me quality work. Okay. If you've got questions, write them down, shoot me an email. Don't forget them so that I can answer them next time I see you. All right. See you guys later. Good luck. Go get them.